So what does electric field stand for? We know that if you have any charge object, it is going to exert a force on another object, and the direction of the force is going to be joining the centers of the two objects, right? But supposing the other object does not really exist, but still one charge object is going to influence any other charge objects in its vicinity. So what does that is known as? That is what is known as the electric field. And from any particular charge object, the electric field, being a vector quantity, is going to be exerting its force along all possible directions. So that we are going to discuss in the next thing, that is the electric field and the electric field lines.
So students, we have so far understood when you have two charges, what is going to be the net force that's going to exist between those two charges. Now supposing you want to find out what is the amount of force that any particular charge is going to produce, right? So that is defined as the force due to or the field due to that particular charge. That is what is known as the electric field. So let's try and understand about what exactly does an electric field stand for. So what exactly is an electric field? When we talk about an electric field, it is the area around a charged particle in which the forces of attraction or repulsion are noticeable. For instance, if you remember in the Coulomb's law, what we said that the force is equals to K Q1 Q2 upon R square, right? So if I say one of the charges is unit charge, so I can just put it as F by Q1 either way. So that is going to give me K Q2 upon R square. So this is the influence of the particular charge Q2 anywhere at a distance R. If I just take the magnitude, not the direction. So this is how we define the electric field. Okay. Now going further, what exactly does electric field stand for? So it is nothing but the vector field associated with the presence of electric charge. That is what is known as the electric field. Electric field is the influence of electric charge on space or the medium itself. Then the direction of the electric field is determined by the direction of the electric force, because you can have the influence existing everywhere along all possible directions, but you can only find out the force only when you have the two charges, because the force is going to exist between the centers of the two charges. So if you put a positive test charge at a particular position, join the centers of the two charges, that's going to give you the direction of the electric field. Now what exactly are the electric field lines? Because you just have one single charge, by convention we say that from a positive charge the field lines are going to go out, and from the negative charge the field lines are going to go in, right? So here, as you can see in the diagram, you have negative charge, the field lines are going inside. Similarly, if you have positive charges, they are going to repel each other. So electric field lines, these are defined as the electric field lines as a path which can be straight or curved, such that if you draw a tangent anywhere on those electric field lines, that is going to give you the direction of the electric field intensity at that point. Electric field intensity means how much is the amount of electric field that is there at that particular point. Yeah. Now, one thing to note here is that no two directions of electric field can intersect. If you have two electric field lines intersecting, that means there are going to be, if you draw a tangent, there are going to be two directions of the electric field. That is not going to be possible. At any particular place, you cannot have two directions of electric field. These are vector quantities, so there is just going to be one single direction, right? So, the important points here. Tangent to the electric field at any point gives the direction of electric field intensity at that point. Okay? No two lines of force or electric field can intersect each other. Electric field lines are always normal to the surface of conductor. For instance, if I say that this is my conductor which has some charges in it, the electric field lines are always going to be produced perpendicular to it. It may not be looking like that it's going perpendicular, the surface itself is looking kind of crooked. So, but the electric field lines are always going to be normal to this particular surface. They're not going to be tangential, mind you. The electric field lines contract longitudinally. The electric field lines exert a lateral pressure. They are going to be exerting a pressure in the outward direction. So these are the properties of the electric field lines. So stay tuned for further on this particular chapter.
Hopefully you would have enjoyed listening to whatever we have discussed in the module. Now, if you still feel that there are any particular doubts that you have, so please visit our site www.askIITians.com. In this, go to the discussion board. Here, you can find all the topics relevant to your questions. You can post your doubts in these relevant topics. And how exactly you are going to do it? Go to the right hand side corner of your screen. As you can see, you can select the category. The categories are defined here. You can select your category, type down your question. You can use your mathematical symbols as well. Else, if you have the question in the form of an image, you can attach the image, post it. We can assure you that the questions would be moderated and answered between 24 to 48 hours after you post it. So keep posting and happy posting. Thank you. Students, hereby we learned about what is the force that exists between a charge object and, let's say, unit charge object or a charge of 1 coulomb. The force that exists between these two objects is what is known as the electric field. We can also define the electric field, as we defined here, as the force per unit charge on which it is being experienced, the force that is experienced on a unit charge. So this was all about electric field. Now we need to understand, we need to go further and discuss further about what exactly is the electric flux. What is electric flux? Flux basically means the amount of field lines. And how do we quantify? We quantify it by saying that how many lines are actually passing a particular area. So the electric field lines passing per unit area is what we understand about flux. Stay tuned when we discuss about next topic, that is electric flux.